The quantum physics theory. It allows us to differentiate from general relativity. GR attributes phenomena to distributes them to interaction between mass anchor and physical lattice. Welcome back to the electronics lab. Today we are soldering a new controller. It just takes a very small amount of heat. This will ensure that our connection is perfect. Let's see how well this brand new circuit operates.
Here's the weird thing about galaxies. Their outer stars don't slow down the way Newton says they should. That flat rotation curve is the anomaly. It's what kicked off dark matter. I'm going to test a different idea. The grid coupling force from the quantum physics theory. Quick primer. Mass-energy equivalence gets tossed. The universe's expanse is a constant, flat, non-density space field. Space grows by adding modular grid units. Big anchors get mass from a Higgs scale effect and lock into the grid. Their tiny mass anchor jitters send out V-waves we call gravity. Rotation might owe a lot to a new term, Fg, gr mh x lx, drdt xo mh, the Higgs scale mass, L, the grid drag coefficient, drdt, the local expansion flux, O, the rotational factor. If that coupling adds torque, maybe no extra invisible matter is needed. How to test on a real galaxy. Start with the anomaly, build a clean model. Step 1. Data, inner disk from H alpha, outer disk from 21 cm at Hi. Goal, velocity versus radius as far out as possible. Step 2. Inclination, correct foreshortened speeds using the galaxy's tilt to get true VER. Step 3. Baryonic baseline, convert surface brightness into stellar mass. Add gas mass, compute Newtonian V(2 plus Vg(2). Now the key move, take the difference, the grid inertia delta, map that delta to Fg by tuning L. Also use estimates of MH, use a local drdt estimate, fold in O from the galaxy's spin geometry, practically do an iterative fit, adjust L to minimize residuals radius by radius. Second check, galaxies in high expansion zones should show systematic changes. Compare many galaxies. Does one L work or does it scale with local flux? Robust inputs needed. Mass maps from surface brightness to set MH. Full 2D velocity fields. IFU surveys or disk fit to catch bars and warps. An expansion flux estimator for drdt from large-scale structure context. Put it on a benchmark like NGC 3198 or M33. If the fit holds flat without dark matter and is consistent across environments, a real signal. If it breaks, a constraint or falsification. Start with the anomaly. Tune the coupling, test across the grid, and let the curves decide. No up, no down, just alignment. That's the hook, no up or down space. Imagine the universe as a space field, a flat, modular grid that everything plugs into. Not a rubber sheet curving under mass, but a clean geometric lattice where motion makes more sense than warping. Black holes don't just twist space-time into a whirlpool. They spin like anchors snapping to the grid, showing their orientation by how they attach to the field. That spin doesn't drag the cosmos into a curve. It reveals the straightness of the space field. Look across the universe and you see the same vibe. Planets, stars, entire galaxies, disks, rings, jets, geometry everywhere. It's unified imagery because alignment beats direction. So what's doing the sinking? Not the usual Higgs story. Think zero-point field, call it the expanse. A neutral, non-density background that everything taps into. Objects don't swim through it, they click with it. Rotation, axis, momentum, these become the language of attachment. Picture a galaxy. Its disk isn't drooping into curvature, it's finding a flat face on the grid and holding it. Stars negotiate their spots by phase and spin, not by sinking. And a black hole, its frame dragging becomes a tell. The spin lines up, the jets point along grid channels, surrounding matter arranges into clean planes. The result, flat geometric alignment echoed at every scale. Do we need a single grand axis? No. Universal rotation isn't the glue here. The expanse is. Alignment emerges locally, object by object. Zoom way out and the tapestry holds. No top, no bottom. Just synchronized celestials, phase locked to the 0 point. Galaxies show us by spin and posture how straight the space field is. That's the quantum physics lens. Flat grid, anchored motion, unified imagery. A cosmos that doesn't fall. It clicks. So next time you see a ring, a disk, a jet, ask, is it curving space, or is it revealing the grid it's aligned to? Maybe the universe isn't bending, maybe it's snapping into place.